Good morning. This session is about building LEO Satellite Constellation using VMware Technology. This may be new. Satellites may be the first time you are hearing this, but we are going to the next level of innovation here. My name is Dharma Rajan, and I work as a principal architect in the Telco and Edge Cloud business unit at VMware. How many of you are here from Telco side? Any of the Telco pro? Good. Now, what you're going to be seeing in this session is terrestrial networks you are building. The next comes non-terrestrial networks. How do you bring them together in the most innovative way? So that's what we'll be talking about. So just to get started is our standard disclaimer. I'm sure you're all seen it, so we'll skip this. Now, the agenda is going to be pretty simple, straightforward. We'll just set a baseline of what is GEO satellites, GEO Earth orbit synchronous satellites, and then LEO, low Earth orbiting satellite constellation. We'll set the base for that. And then using that base, we'll do a deep dive into low Earth orbiting satellites and where the VMware technology will play a role in order to merge all the terrestrial network and non-terrestrial networks. More than 50,000 plus LEO satellites are planned to be launched in the next 5 years. How does container technology help in all of this? That's what we are going to be talking. Now, if you look at the Earth atmosphere today, 20% is where we have a coverage from a cellular network perspective. You are stranded in the middle of an ocean or a desert or in some rural areas, satellite is sort of the way for you to get connectivity. How can we get seamless connectivity across the globe? So how will low Earth orbiting satellites help in this phenomenon? Look at it. Let us first look at what is GEO satellite in a consensus way, and then look at LEO satellites. If you look at GEO satellite, most of you may be familiar. These are normally deployed at around 35,000 kilometers above the Earth, and they typically are very high weight, about greater than 1,000 to 6,000 kgs. And when these are deployed, they are in fixed orbit relative to the Earth. So they're always seeing the Earth. And that way, they have equal rotation with respect to the Earth, and their lifespan, about 10 to 25 years, large lifespans. When you compare that to, we have been deploying GEO satellites for the last couple of decades. There are about 1,500 satellites today in orbit on the GEO side. Now, the large coverage area and it costs quite high. That means they're pretty expensive to build and make because you have to do a lot of static testing, dynamic testing, vibration testing, all of this. Now let us get to the LEO satellite. If you see the compare and contrast here, LEO satellites are very low Earth orbiting, anywhere from 160 kilometers to 2,000 kilometers from the Earth. 50 times closer to the Earth compared to a GEO satellite, very low in weight, and they can be easily built. But the key is they are orbiting around, and as they are orbiting, the drag force, gravitational force of the Earth is going to be pulling it out. So how do you maintain that gravitational force? Then they almost rotate the Earth every 2 hours once. So how do you make this? So you cannot have a single satellite. You have to have a constellation of satellites. That's where the term LEO constellation comes in. And these are pretty small satellites. The cost is also less. So these are some ecosystem characteristics. Let us look at some technical characteristics and how that relates to 5G and where we bring things together from a spectrum point of view. Now, if you look at GEO from a use case point of view, GEO satellites have been used for a long time, whether it's weather prediction or any of that. And because they are positioned at a far away from the Earth, the latency, that's why you can't use it for smartphones and all of that. That is changing. Then, from a throughput point of view, with a GEO satellite, you can get only around 25 megabits per second, but with a LEO satellite, you can go up to 100 megabits. Now, the key here comes in all the spectrum bands and where 5G comes into play. If you look into GEO satellites, we had this very constant band of L band, the C band, KU band, KA band, the V band. all these bands, frequency bands, were at different spectrum ranges. And they were all physical antennas that were made in a geosatellite. When you come to the LEO satellite, you have different band frequencies, the L band, the Ka band, and the V band. Now, start to look at 5G. 3GPP has defined through spectrum bands for 5G, the 450 megahertz and 6 gigahertz range. If you look at LTE was anywhere from 560 megahertz to 2.7 gigahertz. So the L band frequency spectrum of 5G matches well with that of LEO. The second thing, if you look at all the new spectrum that are being auctioned, anywhere from 24.25 gigahertz to 52.6 gigahertz, they fall within the category of K-band and V-band. The challenge we had with geosatellites was because these antennas were all fixed and the spectrum bands were fixed, there was no concept that occurred in terms of spectrum sharing. Comes 5G, where the new radio is everything about software. The BBU units can be transformed into central units, distributed units, RAN intelligent controllers, everything is in software. So dynamic spectrum sharing is possible. And this types of technology where spectrum sharing is possible enables the terrestrial network and non-terrestrial network to communicate. Thereby, connectivity to bring to smartphone directly from satellites or through existing network is very much possible. Okay? That's where the connection comes between LEO satellites and smartphone technology. Now, how is this happening? As you know, probably the earliest of these LEO satellites was the Iridium satellites. Iridium satellites were about 77. This number 77 comes from the atomic number of iridium. That's how the 77 was deployed. Now, all these satellites were deployed at a very high 780-kilometer orbit, typically used in warfare regions or some of this. But the LEO constellation being deployed at a low Earth, you have two separate spatial, and they are rotating continuously. So these satellite needs to have connectivity. How do you ensure reliability, resiliency, and redundancy? So there is something called crosslink. So each satellite is connected to a minimum of 4 other satellites logically. So how do you maintain all of this in software? Right? Those things have to be thought through along with this. Then, so you have one side, you have the space-based assets. The other side, you have ground-based. Just like a typical NOC that you are using for a terrestrial network, for a geosatellite network, how do you use a ground station as a service? That is coming. So these types of asset, as you can see in this picture, the 50,000 plus satellites are planned to be deployed in the next 5 years. You see the amount of space management that has to be needed. And these are satellites, their lifespan is 5 to 7 years. There is no concept of upgrade and patching and all of that. It's a question of rip and replace. So how do you do all of that? Those are the things we will talk about as we go further into this. Now, what is the value here? And how do we provide cellular network coverage, whether it is in air, space, or sea? Who is coming forward and doing it? Or remote areas. Just an example of T-Mobile and SpaceX, which recently introduced a collaboration in order to provide this type of connectivity. This is one example. The other area is how do you supplement a terrestrial network in the case of a disaster that may happen? How do you use satellite technology in order to continue that communication that is happening? So that is the other area. And if you think about climate change and all of that that is happening, LEO satellites can play a vital role into this orbit. Then third, think about, okay, you are going in an aircraft, typically there is a certain period of time you don't get network connectivity. How can I get seamless connectivity when I do flight travel? Broadband connectivity throughout. Right from the time I leave my house all the way I get to the flight and come back. Can I have an office in space? Maybe it's possible. Right? So those are the types of connectivity scenarios that. The other key area is the Department of Defense and others, globally, very specifically in the US, they are looking at different ways. Because if you look at a defense network, it's all mostly 3G, but it's very, satellites are helping, geo satellites are helping. But now as LEO satellites come in, they will have provide coverage at different areas of the network. Now, these are some examples of this constellation. Who really is doing this? I said 50,000 plus satellites are planned to be launched. Already you see that nearly 2,300 satellites of Starlink were launched in orbit, and their target is to launch about 42,000 satellites. Now, the second, OneWeb. OneWeb is a company which is launching satellites, and their technology, how they are launching, it's a complete cloud-native architecture. Now, when I presented this session in the US, that number was 430, and now it is 464. They have a collaboration both with Telefonica as well as with the Indian Space Research Organization, where in one go, they were able to launch 36 satellites. So that is the volume at which these satellites are being launched, rotate about the orbit. Now, there are companies, Amazon has the Kuiper satellites, and then Inmarsat is a well-known company in the US on satellite technology, and they are launching what is called the LEO birds. Okay? So, there's a whole list of other companies, as you can see. Everybody is entering into this space. And some like AST are trying to provide you connectivity both for your 4G phones as well as your 5G phones, existing phones, with some new business logic. So that how can I provide connectivity across different cellular networks? So this is rapidly evolving. Okay? Well, as you say this, what is leading to this evolution? I see four typical trends that is happening. One is as 5G was introduced, the key concept of 5G was the new radio. The radio access network, which was physical, mostly very proprietary in nature, has now transformed itself completely to software. The BBU units have transformed to central units, a distributed unit, RAN intelligent controllers, all in software. That transformation has helped, and that is starting the evolution. Then the evolution of the edge cloud. How closer can I be to the consumer in order to provide them the service that they need? As part that evolution has helped because of the edge evolution, and because I can provide these radio access network closer to where the user is in a terrestrial network, how can I bring that from a satellite network and provide that connectivity? The fourth is the cloud-native nature of the solution, and this is where VMware can. The second area is you see a lot of operational, from a vendor point of view, a lot of collaboration happening. Collaboration between the satellite industry, the communication service providers, that is happening. Examples here is Ericsson, Qualcomm, and Thales. Thales is one of the biggest provider for NATO in all the satellite technology across the world. Then Nokia, Vodafone, and GST. Then with Telstra, then the last one is Reliance Jio and Luxembourg SES here, right? So there's a lot of industries which are collaborating together. Now the very other important thing that is happening is 3GPP. From a standards perspective and from a policy perspective, a lot of changes are happening as this technology forges in. Now 3GPP right from release 15, they have started to include non-terrestrial network into the specification. With release 16 and release 17, there is more and more of this being included. And if you take an example like the US Department of Defense network, it's a 3G network, and they're transforming that to a 5G, with satellite technology being one of the key providers, enablers of that. Third, regulatory policy. Now in space, I cannot have an American regulatory policy, a European regulatory policy, Asian regulatory policy. I need to have one policy, right? So how is all those coming together? That is one. The other fourth, the Federal Communication Commission in the US has started what is called ISAM. ISAM is In-Space Servicing, Assembly, and Manufacturing of Satellites. How can I do that? So there is a lot of effort that is going on in the standardization and policy side in order to help with this technology. Finally, the fourth, SaaS-based model in order to manage this. It's not first to build, design and build this and put this into space, but also how do you start to manage it from a day-to-day operation point of view. That is where ground station as a service is coming into play. Some of the typical examples here is Leave Space, which is using the Google Cloud. Then Microsoft has its own orbital program. VMware, as part of its multi-cloud strategy, can help you to connect across any of these clouds. So these are things to think about as you start to deploy this. Okay? Now, with this said, let us take a look at what is the architecture for such a base of a LEO constellation here. Okay? Now, if you look at this, this is how the architecture will look at from a logical perspective. I said the edge is becoming more and more prominent. At the edge, as you start to build a radio network intelligent for terrestrial networks with 5G connectivity, from a satellite point of view, a non-terrestrial network can be similarly built at the edge as a logical infrastructure. Now, where VMware started? VMware started with virtualizing the core cloud. We have 1.2 billion subscribers who are running on a VMware virtual platform, on a telco platform, every single day for making their telephonic calling. So those we have extended and we have been able to connect to the edge. So now you have the capability to virtualize the core cloud, you have the capability to virtualize the radio network, and then you can start to bring in the satellite network into place. Now, as you do that, where are the places where, So the places where all this works is, if you look at a LEO constellation, there are various things that we can bring in as radio network units, whether it's a control unit or it is a distributed unit. Right from starting with the protocol stack, the satellite payload, we talked about crosslinks, how each LEO satellite has to be connected. Then how do you manage that? How do you deorbit those satellites? And as you bring it down, how do you make sure that the space junk is not staying there? How do you control those things? And dynamic spectrum share. So there is a plethora of software-based entities that you can create, both from a data plane perspective, from a control plane perspective, from a signaling plane perspective, and all of this can work either as an X app and an R app and connect to a RAN intelligent controller. So just like you use a RAN intelligent controller for a terrestrial network, you can also use the radio technology that we have built using virtualization to a non-terrestrial network. So that is the concept. That is why. So suppose you are making a call from a terrestrial network and that other side of the call goes away, how do you use satellite technology? So at the edge itself, you can pass, because you have the ability to do dynamic spectrum sharing, you can share the spectrum and then pass it on to your satellites. So this is the way this technology can start to develop. Now, it becomes pretty much complex as you look into the overall architecture here. So this is the sort of a complete architecture where you see both a terrestrial and a non-terrestrial network together. And if you look at the edge, there are different types of edges that are coming into play here. There could be a far edge, there could be a near edge, there could be a nomadic or a mobile edge. Mobile edges are basically, think of drones, think of warfare scenarios, think of mobile things that are moving, and the network, you may have to dislodge that network at some point of time so that the enemy doesn't get all the details, right? So those types of networks, how do you build it and instantiate it on demand? You can do that because it's a virtual, entirely virtual network, you can create it on demand. So those types of edges have the connectivity. And the beauty of this LEO satellite is not only connect to the edge, but you can also have direct connectivity to the core of the network. Because the satellites are at high distance and they are connecting to the core of the network, you can pass the calls directly from the core to the other end. So that way you have terrestrial to non-terrestrial, non-terrestrial to terrestrial, terrestrial to terrestrial to non-terrestrial. So multiple permutation and combination can be had in this connectivity range. and thereby there is seamless connectivity wherever you are stranded across the world. Okay? That's what this brings to. Now, with that being said, okay, what is that VMware technology that can help with all of this in order for you to build this, right? Now, let us take a look. VMware, as I said before, we have what is called the Telco platform that enabled you to build the core network. Now, what we also have is the platform that can build the radio access network edge. And this one, if you look at the bottom, it's based on vSphere ESXi, the standard, but it uses a real-time operating system. Thereby, you have very low latency sensitive applications can be built, and you can get microsecond level of accuracy. Now, on the top of it is Tanzu. Again, it is optimized for real-time environment. The third on top of it is the automation. So when I can automate all of this, when I have thousands of edges, how can I automate and bring this together? And when I'm using container-based services, how can I do a CI/CD type environment in order to bring this together? Today, what we are deploying is for the terrestrial network, the control unit, distributed unit, RAN intelligent controllers there. Tomorrow, on the same platform, you can logically segment that. One portion for a terrestrial network, another portion for a non-terrestrial network, because everything is software and container-based. Okay? So this is the type of platform that you can start to use for. Now, how does that, where does the intelligence lies? The intelligence again is in the RAN intelligent controller. So the RAN intelligent controller, if you look here, this is all based on ORAN specification. So that way it is open specification, multi-vendor. You can have any vendor of your choice who builds that applications, whether it is a data plane application, a control plane, or a management plane application, for either it is for the terrestrial network or the non-terrestrial network. So if I look into ORAN specification, it's a data plane specification, it is the E2 interfaces which provide you the near real-time rec. And so that's one part of it, which you can deploy either in the far edge, or in a cell site, or in a satellite hub. Then you can also use the ORAN A1 interfaces in order to connect to the management system, and then use the centralized RAN intelligent controllers in order to configure to performance management and all of those types of management related activity or control plane activity. And this is where you can get it to the near edge or to an aggregation point or a satellite. So use Open RAN specifications both for terrestrial network and non-terrestrial network. That way, you can have the freedom of choice in order to bring the application, freedom of choice in selecting the vendor, have a common platform strategy in order to build your network. Okay? With that being said, let us switch into two key aspects of it. I said multi-cloud architecture. You can start to deploy it in different control planes. What you see in the far right is the control plane, which is where we started out with, where we started to deploy the 5G core network. Here, you could bring in all the core functionality, whether it's an evolved packet core or IP multimedia subsystem, from any vendor of your choice, and securely demarcate it using the vCloud Director. That's one type of control plane where you can deploy. And that's a control plane where we have around 1.2 billion subscribers today. The next control plane, you could also use OpenStack. If you want to use OpenStack as a way for a control plane, you could also use that, is also supported. The third is what is emerging is, okay, I have been using virtual network functions, I'm slowly migrating into container network functions, I want to start using both on the same common control plane, that is also supported on a vSphere base. Or I'm building a totally new standalone architecture, I'm going to go everything container based. Can I do that? Yes. You can use that as a control plane. That is where the Kubernetes clusters and all of that come into play. So you can build your control plane across the way you want it across architectures. Now, at the same time, whichever you build it, you can also connect it to a public cloud, if that is what. So this is where all the open specification play a role. Because we are aligned to HC, TM Forum, ORAN and all of that, we provide standard APIs and SDKs so that you can. And from the automation layer, at the time of instantiation itself, you can say deploy this on this edge, or in this private cloud, or in this public cloud, this control. So you have that flexibility in order for the deployment in any type of cloud, any type of control plane that you need. Okay? That is the flexibility that you are getting today for the terrestrial network. You can also start to use that for the non-terrestrial segment. With that said, let me quickly give you a rundown on the automation. There are a couple of sessions at VMware Explore on this area, so I'm not going to go deep. But just to give you a glimpse of this, there are things like you could create a slice of a network just to manage your terrestrial network, another slice of a network just to manage your non-terrestrial network. So network slicing can come. So those are possibility there. Then services, depending upon the type of services you want to instantiate, whether you want to create design template for those services as applications come along, you can do that. The third is how you can automate it because you are deploying containers and volumes. How do you automate all of this process? That whole automation layer exists. And then you have a multi-cloud so that how you can deploy the containers across different clouds and complete infrastructure automation exists. So this is a high-level view on automation. If you have not attended any of the automation session, feel free to look at the videos on that. Now, we talked about the infrastructure, we talked about automation. Next is I deploy all of this, how do I manage it, right? Day 2 operations is very, very critical. And that is where the operations layer come into place. How do I do multi-layer operation management of both the radio network as well as the ground station as a service type of network? So combined these together, combine the operations and the automation together, you get the end-to-end perspective of managing a terrestrial network and a non-terrestrial network of the future. Okay? With that, probably let me say what all we went through. We had a glimpse of what is a GEO satellite network, what is a LEO, what is the differentiation between that, technical characteristic. We related that to the different spectrum bands and who is deploying this, how they are getting deployed, what is the architecture, and how do we run all this entire network to operations. With that, let me stop here. Any questions?
I've got a question.
Please.
Do you plan to use the satellite as an edge to deploy any VMware solution on board of the satellite? Or
We are working on that. We are trying to see, yes, trying to see how the same edge, both terrestrial, non-terrestrial.
let's do Q&A off stage.
Okay, can be worked. Okay, so I'm available off stage. Anybody wants, please catch me up. Thank you very much.